Hello everyone and welcome back to Diksha Karnataka YouTube channel. You are watching KCET 60 out of 60 in physics series, where I am trying to help you to achieve your dream to get 60 out of 60 in KCET 2025. If you are following me from the beginning, then definitely your dream of achieving 60 out of 60 will be very much true. And today we are going to discuss the previous year questions and some important questions from the chapter Units and Measurement. We have already completed the chapter yesterday, so if you have missed that chapter, you can visit our channel and watch that video. So today we are going to discuss about all the previous year questions and then some important questions from this chapter. If you want to get all the updates from the channel, that is when we are posting a video, when we are conducting KPL question paper, which is absolutely free of cost. Only thing that you have to do, you have to join our WhatsApp group. The link is given in the description. Click on the link and then join our WhatsApp group and then click on the bell icon so that you get the notification as soon as we are posting an update. Now let's start with today's topic. First question is the true length of a wire is 3.678 centimeter. When the length of this wire is measured using instrument A, the length of the wire is 3.5 centimeter. Okay, so the length of the wire when measured using instrument A, it is 3.5 centimeter. When the length of the wire is measured using instrument B, it is found to have a length of 3.38 centimeter. Right, so what is the actual length? Actual length was 3.678 centimeter. Now what of the following is true? Right, the measurement with A is more accurate while measurement with B is more precise. Measurement with B is more accurate and precise. Measurement with A is more precise while measurement with B is more accurate. Measurement with A is more accurate and precise. Now what is the meaning of accuracy and precision? Accuracy means how close the measured value is to the actual data. So the actual length is 3.678, and out of these two measurements, that is 3.5 and 3.38, the closest value is 3.5 centimeter. So device A is more accurate. So accuracy means how close is the data, measured data is from the actual data. So in that terms, this is more accurate. And precision means how much close your how many decimal numbers you have after measuring the value. So for example, here we have 3.38. So it has one extra data compared to this, right? So this is more precise because it can measure more decimals compared to A, right? So B is more precise. So A is accurate while B is more precise. So correct answer is option A. So be careful if this question comes in your exam. Now the vernier scale of a traveling microscope. Now this question is based on the experiments that you are performing in your PU1. Okay, so you have used vernier scale, so that's why you need to know how to calculate the least count, etc. The vernier scale of a traveling microscope has 50 divisions, which coincides with 49 main scale divisions. If each main scale division is 0.5 millimeter, then the least count of the microscope. Very simple question. How to find the least count? So least count is 1 minus 49 by 50. Okay, this is the main scale division. This is the vernier scale division. 1 is the 1 unit, and what is the length of 1 unit? 1 unit is 0.5 millimeter. Okay, so this is the simple thing. So 1 by 50, this will be 1 by 50 obviously times 0.5 millimeter. This will be millimeter, right? Simple question. So it will be 1 by 50 times 5 by 10 millimeter. So it will be 10, 5 tens are 50. So it will be 1 by 100 millimeters or 0.01 millimeters. Okay, so the correct answer is 0.01 millimeter, right? Simple question, simple answer. You need to remember this formula, that how you can calculate the least count of a scale. Now the physical quantity which is measured in the unit of Weber per ampere is. So, Weber per ampere is what is the quantity self inductance, mutual inductance, magnetic flux, both A and B. Okay, magnetic flux unit is Weber. Okay, Weber per ampere is the, either you can say it is self inductance or you can say mutual inductance, both have the same unit. So, correct answer is option D. Okay, so this is the correct answer. Now, let us move on. A cylindrical wire has a mass of 0.3 plus minus 0.003 grams, radius 0.5 plus minus 0.005 millimeter. Okay, and the length is 6 plus minus 0.06 centimeter. Then the maximum percentage error in the measurement of density. So, first of all we need to know what is the formula for density. The formula for density is mass per unit volume. Okay, mass per unit volume. Now, it is a cylinder. So, what is the volume for cylinder? Cylinder's volume is pi r square L. Okay, these things you have to remember. So, density is mass divided by pi r square L. Now, what is the percentage error? To calculate the percentage error, you have to do this d rho by rho. Okay, so what is d rho by rho? Very simple. So, it will be dm by m plus, what is the differentiation of r square? Differentiation of r square is 2r. So, while writing that you have to write 2 dr by r. Okay, only the exponent value, what is the if you are doing dr square, d of r square, okay, then you will get 2 dr, right, r times r. So, but when you are dividing it by r square, so basically one of the r will cancel. So, that is why we can write that as 2 dr by r. Everything will be plus dl by l. If exponent is, if there is power is 1, then it will be simply dm by m, like for example dl by l, and if the power is 2, then you have to take the power outside and then you have to write dr by r. Simple, right? Now, what is dm? dm is nothing but the error in the measurement of mass. Okay, so it is 0.03. And what is the mass? Mass is the previous value. Okay, so this is the value plus 2. What is radius? Radius is error is 0.005 and the radius is 0.5 plus what is dl? dl is 0.06 and L is 6. Okay. Now, once you calculate everything, you have to multiply with 100 to get the percentage value. Okay, this is the error. Now, what is the value? 1 decimal will be cancelled, so it will be 0.01 plus 2 times again 0.01 plus again 0.01. Okay, simple. Now, it will be 0.01 plus 0.02 plus 0.01. So, you will get 0.04. Okay. So, 0.04 is the value. So, what is the percentage error? So, percentage error is 0.04 times 100%, right. So, it will be 4%. So, correct answer is 4. Okay. Now, if P, Q and R are physical quantities having different dimensions, which of the following combination can never be a meaningful quantity? So, we discussed this question while we are studying this chapter. So, we found that, see, when we three quantities having different dimensions are considered, okay, you cannot add them or you cannot subtract them. You can multiply them, you can divide, but you cannot, first step cannot be addition or subtraction. This should be clear in your head. So, here if you see this quantity is directly getting subtracted, but P and Q are different dimensions. Different dimension quantities can never be subtracted or added, even though there is a division, but that is coming later. First step you have to do, you have to subtract them. That is not possible. So correct answer is this. So this is not possible. Whereas if you consider this one, first step you are doing is multiplying P times Q, which is possible. Then you are dividing by R, that is also possible, right? Similarly here, what is the first step you are doing? First step you are doing, you are multiplying. Okay, so if you are multiplying, then that is possible, and from there you can subtract Q square, because these two multiplied terms can have the same dimension as Q square, right? So this is also possible. Similarly here, the first step you are doing, you are multiplying. So if you are multiplying, then again this quantity can have the same dimension as R, because even though they have the different dimension, multiplying two quantities will give you a new dimension. But addition and subtraction, they should be done only when they are all have the same dimension, right? So the correct answer is option B. Now, the dimension of the ratio of magnetic flask and permeability are. So very interesting question. So a magnetic flask divided by permeability, they have asked you to find the dimension of this. So what is magnetic flask? Magnetic flask is nothing but magnetic field times area, right? Magnetic flask, we have learned that, and mu is mu. Suppose for example, for now let us consider this is mu naught. Mu naught and mu will have the same dimension. Now what is B? So we have to further break it down. So B equals to, if you remember Ampere's circuit law, even though it does not matter in this case, so in Ampere's circuit law it is mu naught I. A, okay. So BA is mu naught I, right? Why BA is mu naught I? If you remember B dot dA, okay. So mu naught I, but it is with DL, not with A. So what you have to do, mu naught A, and instead of writing area, what is area? Area is nothing but L times L. If you take one of the L out, so B times L equals to mu naught I, okay. So B, if you write A as L times L, length into length, okay, length into breadth or length into length, suppose it's a square loop. So in case of square loop, because we are only considering dimension, it does not matter what is the shape of this, so we can write this as L, okay, and there will be mu naught. Now mu naught cancels, you get I times L. So what is the dimension of I? I's dimension is current. We know that I's dimension is always current to the power 1, and L is dimension of length, so L to the power 1. So m to the power 0, L to the power 1, T to the power 0. So this should be the dimension. So correct answer is option A. Clear? You have to be careful in your mind while doing dimension analysis. You can take the freedom of choosing the objects as per your convenience, okay. You can choose it to be a square, you can choose that, okay, my Ampere circuit law is also applicable. So whatever formula you are going to apply, that should be simplify the equation. Now let's move on to the next question. The resistance R equals to V by I, where V equals to 100 plus minus 5 volt and current I equals to 10 plus minus 0.2 ampere. The percentage error in R is, so we have already know how to solve it. So R is equals to V by I. So we can write this as dr by R. Errors always gets added. So you remember that error always gets added, equals to del dV by V plus di by I. Okay. So what is dV? dV is 5. What is V? V is 100. What is di? Di is 0.2. And what is I? I is 10. Okay. Now let's add 0.05 plus 0.02, that is 0.07. Now this is normal error. To calculate the percentage error, you have to multiply with 100, so it will be 7%. So correct answer is 7%. Now let's move on. The ratio of the dimensions of Planck's constant and that of moment of inertia has the dimension of, so the ratio of dimension of Planck's constant and that of the moment of inertia. What is moment of inertia? First of all, Planck constant. What is the Planck constant? We know that energy is equals to h nu, right? So h nu, where nu is the frequency, h is Planck's constant, E is energy. So h is equals to E by nu. Okay, so this is the, so if you find the dimension of Planck's constant, you can take the dimension of energy and then divide it by frequency. Frequency is basically 1 over time and energy is force times displacement. So you can find the dimension of Planck's constant. Even though we are not going to do it explicitly here, what we are trying to do, first let us find the moment of inertia. So what is the dimension of moment of inertia I? So moment of inertia equals to mr square. We already know that for normally for normal rigid body it is mr square. Now what is E? As I said, E is force times displacement. So its dimension is m l square t to the power minus 2, right? So m l square t to the power minus 2 and frequency is t to the power minus 1. Okay. Now what is mr square? Mr square dimension is m l square. R is nothing but length. So now find the ratio. Planck's constant divided by moment of inertia. What will be the ratio? m l square t to the power minus 2 divided by t to the power minus 1 times m l square. So m l square cancels, t to the power minus 1 and one of them will cancel. So it will be t to the power minus 1. So the ratio is basically, what is this ratio? T to the power minus 1 is nothing but frequency, right? We have already used it here. So basically this is nothing but frequency. So moment of inertia, ratio of Planck's constant and moment of inertia is frequency. Now let us move on to the next question. A physical quantity q is found to depend on the observables x, y and z obeying the relation q equals to x to the power 3, y to the power 2 and divided by z. The percentage error in the measurements of x, y and z are 1%, 2% and 4% respectively. What is the percentage error quantity q? So we already discussed that dq by q. dq by q is 3x 3dx by x plus 2 dy by y plus dz by z. Okay. So this is the addition of the errors. Now because the values are already given in terms of percentage, we don't need to do anything, only we need to put the values. So what is dx by x? Percentage error in x means dx by x in percentage. So that is 1%. Okay. Then what is the percentage error in y? In percentage error in y is 2%. So 2 into 2 plus what is the percentage error in z? 4%, 4 whole percentage. Okay. So 3 plus 4 plus 4 percentage. So 3 plus 4 is 7, 7 plus 4 is 11. So 11%. Correct answer is 11%. Okay. Simple. Which of the following is not the unit of time? So very interesting question. Second, obviously SI unit of time, minute equals to 60 seconds, also unit of time, month is 30 days, then each day is 24 hours, 24 hours is, each hour is 60 minutes and each minute is 60 seconds. So this is also unit of time. But what about light year? Light year is nothing to related to year. Okay, it is the distance traveled by light in 1 year. So this is basically a unit of distance. So this is not a unit of time. Clear? So even though it might seems okay, light year is involved, year is a unit of time, but light year is not a unit of time, it is a unit of distance. If x equals to a plus bt plus ct square, where x is meter and t is in second, then what is the unit of c? Very interesting question. So, what they have given is that x in meter. So, x is basically a unit of distance. Now, we know that when we are adding two quantities, say a plus b, okay, then the dimension of a should be equals to dimension of b, and that should be dimension of the resultant value as well. So, these three quantities should have the same dimension. So, because you cannot add two quantities having different dimensions, right. So, we can say that the dimension of ct square should be same as that of the dimension of x, or unit of ct square should be same unit of x, right. Now, x is in meter, we do not know what is the unit of c, okay, and t is t square is given. T square means time, time means second square. So, c is meter second to the power minus 2 or meter per second square. So, meter per second square is the answer. Okay, you do not need to consider a and bt, you can ignore them. Only two quantities which you are asked about, consider these two quantities and then solve it. Okay, simple. Now, which of the following physical quantity has the dimension formula m to the power 1 L square t to the power minus 3. Now, we know that m L square t to the power minus 2 is work, right, or energy. Okay. So, work or energy is m L t to the power L square t to the power minus 2, because force times displacement. Force is m L t to the power minus 2. When you multiply with one extra distance, it becomes work, also it becomes energy. Work and energy have the same dimension. Now, when you divide it with another t, then what is that value? Work divided by time, work per unit time, that is called power. So, power has one extra to the power minus 3 in its dimension. So, the correct answer is power, right. Now, let us move on. The dimension of universal gravitational constant, another interesting question, usually comes in your PU board exam as well. So, what is the formula? So, first let us write the formula. F is equal to g m m1 m2 by r square. Now, what is the dimension? In terms of dimension, force is m L t to the power minus 2. So, dimension of force should be in your fingertips. You should always remember the dimension of force. This is a very critical quantity involved in many other quantities as well. So, if you remember this quantity, then you can use this force dimension to find the dimension of other quantities as well. So, equals to g m m. So, m square divided by L square. Okay. So, r is nothing but distance. So, its dimension is L, and L r square is there. So, L square, dimension of m1 is m, m2 is also m. So, dimension will multiply and it will get m square. Now, let us find the dimension of g. So, m from this side 1, it comes to that side. So, it will become minus 2, L 1, this was in division. So, this will go up and it will become plus of 2 t to the power minus 2. So, it will become m to the power minus 1 L cube t to the power minus 3. If you remember this well, if you do not remember, you can calculate and you can write the answer. Okay. Sorry, I made a mistake here. It will be t to the power of minus 2. There is nothing happening to the t, right. T to the power minus 2 was here, t to the power minus 2 will be here as well. Now, which of the following is dimensionless? Another interesting question. Force divided by acceleration. Force equals to ma. So, force divided by acceleration will have mass. Velocity divided by acceleration, obviously two different quantities, they will have different values. Volume and area, volume is more, area is one dimension less. So, they are also not dimensionless, but energy divided by work, energy and work both are of same unit, same dimension. So, energy divided by work will be a dimensionless quantity. Okay, energy and work are one or the other, are the same thing, but they are used in different cases, but energy and work have the same dimension. So, when you divide energy by work, the resultant quantity should be a dimensionless quantity. The dimension of Planck's constant equals to that of another interesting question. The dimension of Planck's constant is equal to the dimension of angular momentum. You need to remember that. Okay, dimension of Planck's constant is equals to angular momentum. Okay, moment of inertia, we saw moment of inertia. If you divide Planck's constant divided by angular moment of inertia, you get t to the power minus 1. So Planck's constant should be equals to t to the power minus 1. This is nothing but angular momentum. Okay, so angular momentum and Planck's constant are having the same dimension. The respective number of significant figures for the numbers 23.023, 0.0003 and 2.1 times 10 to the power minus 3 are. So what is the significant figure for this? 1, 2, 3, 4, 5. Okay, everything is significant. This 0 is sandwiched between the other numbers, so it is significant. Now here in this case we ignore of everything, only this is significant. Okay. Now in this case we do not consider this, only 1 and 2 are significant. These two digits are significant. This is scientific notation, so this is not significant. We will not consider this as part of the significant digit. So it will be 5, 1, 2. 5, 1, 2. So correct answer is option A. Okay. Now an object is moving through the liquid. The viscous damping force acting on it is proportional to the velocity. Then the dimension of the constant of proportionality is. So what is the viscous force? Force is F. It is proportional to the velocity. Okay, force is proportional to the velocity, and if you remove the proportionality, you will get a proportionality constant. Now they have asked you to find the dimension of this constant. Simple. So what is the dimension of force? I told you ml t to the power minus 2. You have to remember that, equals to dimension of k. We don't know. What is dimension of v? V is ml t to the power not m to the power 0 obviously. Velocity does not have m. L to the power 1 t to the power minus 1. L t to the power minus 1 is the dimension of velocity. So now let us cancel whatever can be cancelled. So L cancels, and it will become k equals to m L to the power 0 t to the power minus 2 plus 1. This will come this side and it will become plus. So it will become m L to the power 0 t to the power minus 1. So this is the dimension of this quantity. So from the expression we can see that obviously only one quantity has L equals to 0 dimension. So that is option D. Now next question. Two quantities A and B have the different dimensions which mathematical operations given below is physically meaningful. Okay, A and B have different dimensions. Okay, now they are having different dimensions, so A equals to B is not possible, right? Now since they have the different dimensions, you cannot add them, you cannot subtract them. So these two are also not significant, meaningful. So only correct answer is A by B. A by B is possible because you can divide quantities having different dimensions. For example, pressure equals to force by area. Okay, force has some dimension and area is completely different dimension, but still you can find pressure by dividing force by dividing area. So this is a meaningful calculation. Now next question, multiply 107.88 by 0.610 and express the result with correct number of significant figures. So you don't need to multiply in this case. Okay, multiplication figure, if you see the answer is already given same. Okay, 65 point something is the answer. Only thing that you need to determine is the correct significant figures. Okay, because you are multiplying, your result should have the minimum significant figures in these two digits, these two multipliers, right? So if you see, it has 1, 2, 3, 4, 5 significant digits. This has 1, to 3 significant digits. Okay, remember that this 0 is significant because this is coming after the decimal. So after the decimal, if it is not between if it starts with 0.00, then that 0 is not significant, but if it is 50.0, okay, or 0.50, that 0 is significant. You need to remember that. So 3 significant digits here, but since you are multiplying these two numbers, the result should contain only least number of significant digits, that is 3. So your correct answer should be 65.8, that is option D. Very careful when you are answering such questions. Okay, you might be tempted that okay, there are 3 decimals, so correct answer should be this. No, it does not depend on the number of decimals, it depends on the least number of significant digits. When you are adding or subtracting, in that case you have to consider the least number of decimals. Okay, but when you are multiplying or dividing, you have to consider the least number of significant digits. These two are very confusing, so that's why I gave you this question. Young's modulus of a material has same unit that of. Now let us remember what is Young's modulus. Young's modulus is nothing but stress by strain. Right, now strain is a dimensionless quantity because it's just a ratio of lengths. Okay, so it is nothing but its dimension. When you are comparing the dimension of Young's modulus is nothing but F by area, force by area. What is force by area? Force by area is also called pressure. So dimension of Young's modulus should be same as the dimension of pressure. Simple. Strain is a dimension less quantity, compressibility is only 1 by volume, force is obviously not. So correct answer is pressure, and I hope you enjoyed today's session. It was brief, but most important questions from this chapter we have discussed, and I hope this will help you. I will be back with motion in a straight line tomorrow. Till then, bye bye.